Welcome to Meliora's channel, your go-to place for C# and data analysis tutorials, products hands-on demos, and insider secrets to keep you at the cutting edge of innovation. Our goal is to break down complex tech topics to a level that you will easily understand to supercharge your skills. Without further ado, let's jump right in.
In this lecture, we're going to be talking about the DML statements, that is, the data manipulation language statements. So in the last couple of lectures, we've created our MelioraDB database, as you can see here, and we've successfully created and populated the employee data table. So it's going to be in the MelioraDB database tables, and you can see the little arrow. We'll just click it to then see our employee data table. Now, I just want to quickly go over our tables. So we used the query line to import the CSV into our table, but there's actually a way to do this using the MySQL Workbench table data import wizard. So all you need to do is right click and then it's here. We're going to see how to use this when we are working with the department table, which is the last table we're going to use in the series. So if you see, there's a little arrow beside the employee data table, and then that's just containing some information relating to the table, such as the table column. So if we expand this folder, we see ID, first name, last name, date of birth. So all the column fields of the table, And then here we now have our indexes. So in MySQL, well, table indexes are just ways so that are used to find values in columns faster. So it's easier when the column is indexed for MySQL to find values in it. So you can see when we expand that, we have primary. So if we can see more here, it's the primary key. So the primary key on the table is automatically indexed. And you can see its type of B tree. The other type is hash, but you don't need, we are not going to go into that. So that's what I need to know. So it just finds the values here faster. And then we now have foreign keys. So any foreign keys that are relating to other tables will be here. So we have discussed the concept of the primary key, which is the unique identifier for each row, the column that has the unique identifier for each row. So so a foreign key is a column in a table that is a primary key on another table. We're going to see an example of this when we create the department tables, and we're going to now link this column here, department code, to the department table, because department code is a primary key on the department table, which we're going to see later. And then the last thing after foreign keys, we now have our table triggers. So these are programs you can define to run automatically when certain operations are run on the table. Usually we create triggers for inserts and update statements. Okay, so we're going to see each of these. Well, we've already seen this, and we're going to see the foreign keys and the triggers later. So let's go on with today, which is our data manipulation language statement. So these are data manipulation language statements. So these are statements that are used to actually interact with the data contained within the database tables. So the data definition is used to create and define your database objects, whereas this is used to interact with the data contained in these objects, especially your tables. So we have select, update, insert, and delete. And you're going to take a look at the select, which we've already been writing. We're just going to get a more expanded view on it. And I think we've already seen the insert in the last lecture when we're doing the employee data table as an example. So let's now go over the structure of the basic query. Okay, so I just put the definition of syntax here, which is a unique set of guidelines. It's a predetermined structure of how a language is supposed to how it's supposed to be structured with the symbols and everything. So this is the basic SQL query syntax. Now, this is just the where is optional, but this is usually what it is. Select something from something where something. So we're actually going to write select, and you can choose the columns you want to return from your table. The asterisk, which we've used before, is all, and then from is you are now going to select the data, the table the data is contained in, or the table or tables the data is contained in, and where is to filter for conditions. And then I wrote that to add filter for multiple conditions, we want to add an and clause in the clause in the where clause to join various conditions together, so it filters for those two at the time. Okay, so let's go back and start typing these out. Okay, so let's go ahead and see how we've been using the basic query structure. So first of all, let's use the use statement so that it knows that we are querying the table from this database. And then we're now going to just write a select all from that table. Okay. Okay, so we now have all the data from the table. And we can also use the limits clause. Let's remove that. So because the table we're currently working with is very, very small, so we can confidently select all. This asterisk just means all, so it's selecting all columns. But if you have a larger table, you may want to limit the amount of rows that you're getting back. So let's limit this to say 5 rows. And we can see that we're just getting the first 5 rows of that table. Okay, so that's just another useful clause to know. So again, we're selecting all from and then the table name, limits, and thus. Now, let's use the where clause. So let's say we want to select all from the employee data table, but only for employees in department 200, or in the department with code 200. So we would simply write where. So we'll simply write this. So we want to select all from the employee data table where the department code is equal to 200. So we only want employees with department code 200. Okay. And that is what we have. So this is the where. Now, what is actually happening here? So it's filtering for this value here in the department code column. And anywhere it gets a match, it will then, this query will then return it, and anywhere it doesn't get a match, it will not return it. Alternatively, so this is what we call the equality. So this is where it's equal to this. We also can negate that by simply writing an asterisk in front of that equal sign. So now we are saying that we want to select all from the employee data table. So let me read it this way. So give me all the information of employees in the employee data table where the employee is not in department 200. That is essentially what we're saying here. And if that's the case, you can see that now we are getting all department codes returned except for department 200. So that is our negator. Okay, so I've just shown you the not equal to and equal to. We also have less than, greater than, less than or equal to, and then greater than or equal to. These are all equalities we can use in the where clause to filter for conditions in the table. Okay, let's so we've gone through the first two, and let's go ahead and see how we can use the other ones as well. Okay, so let's go ahead and change this up. So let's actually select all the staff whose salary is greater than 60,000. Okay. And this is what we have. So we can see that we do not have any staff here whose salary is below 60,000, only above. Now, if we want this query to be inclusive of 60,000 itself, then we want to write greater than or equal to 60,000. And if we run that, then we now see 60,000 is now inclusive. Let's try maybe 70. Let's remove the greater or equal to. Let's just say greater than 70,000. And there we go, about 3 staff. We can also filter this table by sex. So if we simply write where the sex is equal to F, we are now effectively going to find all the female staff in this table. And there we go. So these are all the female staff: Alice, Nancy, Mary, Andrea, and Anne. Okay, so next thing I want to introduce is some arithmetic functions or operations that we can do in SQL. So, and also some SQL functions themselves. But before we go into that, I want to quickly go over the update feature again. So the update allows us to update particular records in a table. One thing is, now that we have a primary key, which again is the unique identifier in the table, it's very important to have a primary key when you want to run update statements. Because if you don't add a where the primary key is equal to this, your update statement will update everything into the value that you specify. Okay, so let's just see how that goes before I continue. So it's basically update, and then you're going to write your table name, and you're now going to write set, and then the column, we're going to update the salary column, and we're going to change, let's give someone, let's give Anne a salary of, let's add 5,000 to her salary, and then we're now going to add a where. Okay, so we're now going to write where ID is equal to YV1010. So that's Anne. So we should see, if we run this selectly, Anne's salary should go from 70,000 to 75,000. But let's just see. So it's very simple. Update, you write the table you want to update, and then you set your column equal to the value that you want to change it to, and then you now specify exactly where in your table, what row in the table you want that to happen, which is where the primary key comes in very handy. And if you notice, I used backticks to encase the ID. This is simply because some words are called reserved words. So if you use them on your table, you want to just be careful when you're using them in queries, because sometimes the queries may fail. It's just good practice. So things like ID, value, and well, those are the two ones that I've mainly seen, but you want to make sure you encase them in backticks. Now, some servers will enforce this more rigidly than others, but regardless, it's just good practice that you always keep in mind to check your column names, and if you see any reserved name, you always put it in backticks for any query. And after that is run, then we want to simply select all again from the table, so that we can see that effect, that change takes shape. Okay. And after we've run that, we can now see Anne now has a salary of 75, no longer 70. Now, what exactly would have happened if we tried to run this without adding a where clause? Well, we're not going to do that on this table. Let's create a dummy table. Let's say called dummy. And let's now specify. So we're going to have the dummy ID, and this is going to be, let's just say it, an int, and this is going to be the primary key of this table. And then we're just going to have the dummy underscore name. And this is going to be, let's just make this text instead of varchar this time, because I don't really have a plan or to specify exactly how much text I'm going to put in dummy name. So let's just make it as big as possible. So let's go ahead and run. It's created that again. If you want to see the changes, let's refresh. And now we have that table dummy. So let's just select all from that table. And then let's insert into the table, specify the columns. And then the values. Now let's go 100 and let's call this random. Okay. Actually, let's insert like about maybe 3 columns. Let me just put that down. What just things like that. Okay, so so you can insert multiple values into, this is very good for saying you can insert multiple values in the table by simply encasing them in the brackets, then comma, and then again. So we're just going to insert a total of 3 rows into this dummy ID. And then after we've done that insert, let's go ahead and select everything from that table. Okay, so now we have the 3 rows inserted. So let's now go ahead and do what we want to do, which is to use our update. Let's just go ahead and write set it's going to be a varchar, so that's just RA. And let's end it there. Yeah, so what if we do this? We don't have a where clause to specify the exact row where we want to make this change. So if we try and run this, we're going to get an error because by default you will be using the safe update mode. So let's just click that. And you try to update a table without a where that uses a key column. And I recommend you always leave this mode on so it prevents these kinds of things. Because if this had run successfully, what you would see is that all the dummy name rows will then contain RA. So all that data will just be changed entirely. But if we add a where, and then specify that we only want this change to the row where the dummy ID is 300, and again we select all from that dummy table, then you see that that works because we've now specified exactly where we want this update to happen, and we can see that the update has definitely happened in that specific row with the ID there. Okay, so that's just a note on the update. So you want to always make sure that you are using a where to specify the exact row that you want this update to happen to prevent that kind of situation. And by default, your MySQL workbench is always going to start up in the safe update mode where it won't actually allow you to run any update statements without this where. Okay, let's go ahead and drop that table. Or I think I'll just leave it for now in case I want to show anything else. So let's just go back to our employee data table. Again, let's just return the first 5 rows. Okay, so this is what we have. So now I would like us to start talking about functions in SQL. So I'm going to go over some certain functions. Okay, so these are some of the functions we are going to go over. So we have count. This is a function that counts the number of rows in a table. And if you pair this with the where clause, it's only going to count certain rows that match a particular criteria that you specify. We have year. This is going to return the year when you pass in dates. Like an array of dates is going to be return the year of the date. And we have min. This finds the minimum in an array. Maximum, it finds the maximum in an array. We have sum, which sums up things together. And then we have average. And aside from year, all the other functions mentioned here are things called aggregate functions, which simply means that they get multiple inputs and then produce a single output. So that's why they are called aggregate functions. Anyway, let's go ahead and start with the count function and go down from there. Okay, so say we wanted to count the number of employees in this table. We would first of all, we'd also still use the select, but then we'll then use count, and then we are now going to write, either we write count all, but I'm just going to write to count the ID column, which is the primary key column. And now I'm going to just write the table. So it's just going to count all the number of rows in the ID column. And the reason why I did this is simply because the ID column is the primary key column, so it's not nullable. So it will never have any null values. So the amount of data in it does correspond to the amount of records in the table. So if we run that, we'll then have count ID, and then the number is 10. So you can see that it just automatically gives the name of the function and what it counted here. Now I'm going to quickly show you the alias. So we can customize the names that we want our outputs to get from our queries using the as keyword. So let's call this employee number. So we want to count all the number of people inside the employee table as the employee number here. So if we run that again, now we see that it's nicely has a name, employee number, and then the amount is 10. So we have 10 employees in this table. So that is what count is doing. But that is not only what count can actually do. So if I write to count the ID, let's count the number of staff in the department with code 400. So let's call this something like employee underscore dep 400. And to do this now, we are going to introduce a where clause where we are actively saying that only count employees in that table whose department code is 400 and give me the results using the name employee underscore dep 400. And we get 2. So we have only 2 employees who are in department 400, and we can simply double check this by removing that whole thing. And let's just do a select all from employee data, just a normal query. And we can see that we only have 2 staff with department 400 in the table, which is exactly what the count returned. Another function that we can use is the year function. So the year extracts the year from dates. So if we run the year function, for example, here, we are going to get 1980 back. And then if we run it here, we're going to get 1985. So this could be used to filter based on especially the date of, it's mostly for dates. So we're going to use it on the date of birth column. So let's go ahead and let's select people who were born after 1990. So let's select staff who were born after 1990. Okay, so we're going to select all from employee data where the year of their birth is greater than 1990. And we have no staff meeting that criteria. Let's change this to 1980. And now we have staff that meet that criteria. Oh, and we had someone born exactly on 1990. This is really good because this shows that you can see we're using greater than only and not greater than or equal to. So let's change this back to 1990. And then if we now add the equal to sign, we should now get 1, which is Andrea. Because now it's not only greater than 1990, but also inclusive of 1990. And there we now have her as the sole person in 1990. Okay, now that's the year. So it's just getting the year DOB and it's then, so 1990, so it's then comparing it with these values. So we also have the summation where we can sum a group of things. So let's just do a very simple one. Let's sum the salary column and let's call the result the monthly payout. So we're summing everything regardless of department, sex, or anything of the sort. So select sum salary as monthly payout from there. And then we now have the monthly payout as 725,000. So we've just summed all the salary. We can also do the same thing here with average. So we can get all the average salaries. Let's just call it average salary. And then we have average salary, which is 72,500. The minimum and maximum functions also work similarly. So we can find, if we just replace this here, we can have min. Let's just do min, and then I want to go into more on these as aggregates functions. So we can do that, and we can call it as min salary. So we can just find the person with the value of the minimum salary in this table, which is 50,000. Now I want to quickly go back to our summation function where we summed the salary of the staff. Now, so this is just summing the salary, and I think we use the as keyword save it as something. Now I'm going to introduce a particular clause known as group by, and this is commonly used when we are using aggregate functions and we are returning multiple rows. So if I add multiple columns, so if I add another column here, and let's use the department code so that we can sum the salaries by the department code. from employee data, we are now going to need to add a group by clause to specify that we want to group it by this additional column that we have added. And this is now what we get. So for each of the departments, we are now getting a salary. And you can see that the sum of the salary is not ordered in any particular way. And that is where the order by clause comes in, because it will order the results of your query either in ascending or descending order. So we always want to put order by after a group by clause. And it's just going to be this whole area here, sum salary. And the default order by is by ascending, but we are going to use desk to signify that we want this ordered in descending order. Okay, and that's what we have. So the highest sum salary is in department 200, the lowest sum salary is in department 400. So those are just some examples of your group by and order group by, and they are used with aggregate functions in SQL. Okay, so we've made some really good progress in, but we're going to see a lot more functions and a lot more clauses in as we move through. But right now, I want us to explore more about the attributes of these tables. So we've seen our columns, we now understand our indexes, or what the indexes of the tables are, which primary keys are automatically. And now I want us to explore foreign keys as we move through more of our DM data manipulation languages and all that. So to help us with our understanding of foreign and primary keys and their relation to table relationships, let's go ahead and create the department table and then import our CSV data into it. So this time around, we're going to be using the table data import wizard. Just going to call it departments, and we're going to have our dep underscore ID, and this is going to be of type int, and this is the primary key of the table. And then we are going to have our dep underscore name, and then this is going to be of type, this time it's just going to be a variable character, because I believe I only need 100 for this table. Oh, like you do not put commas in between the column names and their data types. Okay, so let's create our table again. Refresh to then get our table there, and let's drop this table dummy. I don't think we may use it again, and even if we have to, we'll just create it again. Okay, so that's gone. Let's refresh. So now we have the department table, and also it has its own, we have its columns here, its indexes, which is again automatically indexing the primary key, foreign keys, and then its own triggers. So now let's select all. Let's go ahead and select all from departments. Now we can see it's just an empty null table. So let's now populate it with data, and in the next lecture we're going to continue. So let's right click. We're going to get the table data import wizard. We're going to, so it's departments, next, and we're going to use an existing table, which is the department table. We're going to go next, and we're just going to map the values to the column. So 100, yes, goes in dep ID, operations, which is the name, goes in the dep underscore name. And we're going to click next, and it's just going to prepare to import all that data. And then we now have 6 rows imported, and we can go ahead and click finish. And now let's run this query again. And this is now what we have. And this is now what we have. So we have 100, 200, and all etc. Okay, so that is it for now. Okay, that then brings us to the end of this lecture. In the next lecture, we're going to explore the newly imported table, and we're going to learn how to create referential integrity by creating constraints on the employee table by assigning the foreign key equivalent on the employee table from the primary key in the department table. Okay, thank you so much for watching, and I'll see you in the next lecture.
Thank you for watching, and if you learned something new or enjoyed this video, be sure to show us support by clicking like and subscribe. Your support helps us to bring you even better content, so stay tuned for the next exciting video. You can also click the link below to see other free and paid videos on other exciting topics. If the click did not work, kindly copy the link and paste on your browser. Thank you, and see you in the next video.